Hello, everybody at LRVS, day two. We hope everybody's enjoying it. We're having a great time. It's rocking. And let's keep the momentum going. And I'm pleased and honored to introduce Jade Thompson. Jade is a condition monitoring laboratory manager at Practice Care Maintenance Services, and she will be discussing the dangers of blind filtration. Obviously, this introduction does not do Jade justice because you can find out more about her and connect with her in the speaker profile. And also, you see Jade's code in the lower left-hand corner. I hope it's in the left-hand corner. And also, reminder that there will be a Q&A afterwards. So get your questions ready, put them up in the chat, and we'll line them up, and we'll get them after the presentation. So let's get going. Thank you very much for your time, and enjoy.
Thank you. Hello, everybody. I'm Jade Thompson, Laboratory Manager at PCMS Engineering. Today, I want to talk about the dangers of blind filtration with regards to reliability. The reliability and lubrication industry has seen many new and improved technologies over the past few decades, from improvements in lubricants and filters to remote or inline analysis for most condition monitoring technologies. These improvements and developments have contributed to a change in culture, where now the majority of businesses strive for reliability and proactivity rather than just the market dominators. This culture shift puts demand on our industries to improve our monitoring, analysis, and filtering at lower costs with better results and a zero failures outcome. We are in a cycle which is working to improve much more than profits. We're trying to revolutionize reliability. To achieve this costs money, and this leaves the industries which should be working together, fighting for that top spot. The road to reliability is a crowded journey. So what is reliability? Reliability is consistency. Consistency can be disrupted by so many factors. And as reliability providers, it's our job to help prevent these factors affecting the consistency of the assets. Everybody wants a reliability site with reliable assets. So the question is our approach reliable? Do we have the correct principles and goals in place? Do we need to work on training and culture within the company? Are the processes sufficient and efficient? Is the reliability approach optimized to our site and operations? And is this approach sustainable for years to come? And what does reliability have to do with lubrication? After all, oil is oil. Wrong. Lubricants can help or hinder the reliability journey. Without correct lubrication, an asset can never be truly reliable or productive. Lubricants should be treated as a component within the system. Therefore, we're trying to improve the reliability of our lubricant, in turn to improve the reliability of the whole system. The reliability journey should ideally begin before the asset's even installed, and choosing the right gear for the job gives you a good head start. There is no one technology or service which can solely achieve reliability on it. There are many recipes for reliability, all of which differ due to the variables of real life, machinery, production, and operation. The task many of our customers have is making a choice between which product, service, and supplier to trust. The issue of having to choose is usually down to finances. It's what's driven the industry into a competition between products rather than a competition between customer service. The customer is the one who is left exhausted trying to figure out what he requires with conflicting products and services being offered. As a reliability industry, we must work together to ensure companies have an honest awareness of reliability and lubrication. Without the correct knowledge, how can we expect to achieve reliability? We hear all too often customers or even technology specialists dismissing other tools of the trade, when in reality, these tools can work alongside each other to create a much more informative picture. Why test the lubricant? Just filter it. Use the colour as a guide. Vibration will be sufficient. All comments which will not help the reliability process. Asset reliability. So what are the options? Achieving asset reliability is a multi-skilled, multi-tooled task, which can vary massively between asset types and operating environments. There is no one fit suits all. Our choices for reliability must be reliable. Do we have evidence or logic to back up these decisions? It's very difficult to achieve proactive maintenance without incorporating the rest of the tools on this infographic. We can't expect to achieve proactive maintenance without monitoring, data analysis. We need to work together. So how do we make lubrication reliable? It's the same as the asset reliability process. Many pieces of the puzzle will contribute to true lubricant reliability. Effective filtration will ensure contaminants do not contribute to lubricant failure. Analysis will allow changes to the lubricant to be identified and rectified. Other technologies such as vibration, ultrasound, and thermography will also allow us to identify if the lubricant is sufficient, but also give us a heads up on environments which may lead to lubricant failure. Procedures and correct site culture, or positive site culture, will ensure lubrication routes allow for correct lubrication every time. Correct data analysis will allow us to compare lubrication reliability per asset, but also across sites and industries, so we can learn from each other. Data, along with verification, is vital when considering root cause analysis and general monitoring of the assets and lubrication. We also want to ensure lubricant consumption rates are sustainable. You wouldn't change a healthy bearing. Let's not change healthy lubricants. The more lube changes, the more opportunity for error. Unnecessary changes increase the risk of failure. So we move on to filtration. Why bother? We all know that contamination is the biggest cause of failure in most mechanical assets. Depending on the contamination present will depend on the type of mechanical wear or lubricant failure which may occur. Inline and offline filtration both attempt to prevent contaminants circulating the system and potentially affecting the functionality of a system. There is a whole field based on types of filtration for different contaminants, lubricants, processes, and industries. However, we'll have to save that for another day. Today, we want to understand what we have become blind to. The picture on the right shows an example of a wear plate which was affected by weld splatter debris. We found the debris weld splatter in the filter debris analysis, and then on physical examination, we found the following. So what about the data? So filters keep our components safe from contaminants. But to be truly proactive, surely we don't want to risk these contaminants having any contact, especially in our critical systems. However, you've got the best filtration setup possible, so now the oil analysis or visual inspections show no cause for concern. It's all in the filter hidden away, so we'll test the filter. We can effectively identify particles, wear modes, and contaminant types. We can then use this information to diagnose how these contaminants are being generated and how they are ingressing into the system. Then comes the real reliability practices. We can prevent these oil degrading, asset crunching contaminants getting in there in the first place. This doesn't render the filters useless. Seals wear, breathers wear, and operators wear out. There will be another contaminant another day. We are just trying our best to not throw away all the important data without at least taking a look first. As you can see on the picture on the right, this is from the same system as the wear plate shown on the slide before. The lubricant patch is clear and the lubricant analysis was clear also. But after extracting debris from the filtration system, we can see there's lots of adhesive and abrasive wear, and we can see the weld splatter particles, which most likely initiated the wear process. So once we've taken a look at the debris from the filter, we can use this information to provide a pretty clear picture on the effects that the contaminants have within the system. We can then use this to put practices in place to ensure reoccurrence doesn't occur. As can be seen on the right, we have got some pretty useful information on wear debris and contaminant types. However, let's think about the types of contaminants that may be introduced on changing a filter insert. Culture and staff need to be on board with this battle, but also management. So during filter debris analysis, the information can also be used to extend filter change intervals or change filter types to a more efficient filter type. This would reduce the risk of failure due to intervention. saves some money, and also gives a really good reason to get the filters assessed in the first place. In conclusion, the dangers of blind filtration is a failing system going unnoticed. The use of multi-technologies on critical assets is vital for asset and lubricant reliability. Thank you for listening, guys.
Jade, that was great. Thank you so much. We're waiting for any questions to come in, and if you have any comments or anything follow up with that, please share. But I'm trying to see, we have just a lot of shout outs at this stage.
No worries. I was a bit faster than I thought. Sorry, guys.
Super fast. You came, yeah, that was like 11 minutes and 30 seconds. So it was super fast and everything. But bravo, it was very informative. It was really generous. It was great. So we'll have this on our records, and this will be able to be shared with the attendees and all that. So
thank you.
Jade, thank you very much for your time. I appreciate it.
Lovely. Thank you. Thank you for having me on.
Absolutely. Take care.
You too. Bye.